Okay, late good afternoon. I'll continue reading on the Wikipedia article here for the Raspberry Pi. Performance. While operating at 700 MHz by default, the first generation Raspberry Pi provided a real-world performance roughly equivalent to 0.041 G-flops. On the CPU level, the performance is similar to a 300 MHz Pentium 2 of 1997 to 99. The GPU provides a 1 gigapixel or 1.5 G tensor of graphics processing or 24 gigaflops of general-purpose computing performance. The graphical capabilities of the Raspberry Pi are roughly equivalent to the performance of the Xbox of 2001. Raspberry Pi 2 v1.1 included a quad-core Cortex A7 CPU running at 900 MHz and 1 GB of RAM. It was described as 4 to 6 times more powerful than its predecessor. The GPU was identical to the original. In parallelized benchmarks, the Raspberry Pi 2 v1.1 could be up to 14 times faster than a Raspberry Pi 1 Model B+. The Raspberry Pi 3 with a quad-core Cortex A53 processor is described as having 10 times the performance of a Raspberry Pi 1. Benchmarks showed the Raspberry Pi 3 to be approximately 80% faster than the Raspberry Pi 2 in parallelized tasks. The Raspberry Pi 4 with a quad-core Cortex A72 processor is described as having 3 times the performance of a Raspberry Pi 3. Overclocking. Most Raspberry Pi systems on chip can be overclocked. Might want to pause and read that. To various degrees, utilizing the built-in config.txt file in the boot sector of the Raspberry Pi OS. Overclocking is generally safe and does not automatically void the warranty of the Raspberry Pi. However, setting the force turbo option to 1 bypasses voltage and temperature limits and voids the user's warranty. In Raspberry Pi OS, the overclocking options on boot can also be made by a software command running sudo raspi-config on Raspberry Pi 1, 2, and original 3B without voiding the warranty. In those cases, the Pi automatically shuts the overclocking down if the chip temperature reaches 85 degrees Celsius, 185 degrees Fahrenheit, an appropriately sized heatsink is needed to protect the chip from thermal throttling. Newer versions of the firmware contains the option to choose between 5 overclock turbo presets that, when used, attempt to maximize the performance of the SoC without impairing the lifetime of the board. This is done by monitoring the core temperature of the chip and the CPU load, and dynamically adjusting clock speeds and core voltage. When the demand is low on the CPU, or it is running too hot, the performance is throttled. But if the CPU has much to do and the chip's temperature is acceptable, performance is temporarily increased with CPU clock speeds of up to 1.1 GHz depending on the board version and on which of the turbo settings is used. Overclocking modes are none, 700 MHz ARM, 250 MHz core, 400 MHz SD-RAM, 0 overvolting. I won't read the whole chart. Maybe pause and study if that's interesting to me later. You can always look at the Wikipedia page again. I'll read this though. Overvolting. 6 overvolting. In system information, the CPU speed is indicated as 1200 MHz. When idling, speed lowers to 600 MHz. In the highest turbo mode, the SD-RAM clock speed was originally 500 MHz, but this was later changed to 600 MHz because of occasional SD card corruption. Simultaneously, in high mode, the core clock speed was lowered from 450 to 250 MHz, and in medium mode from 333 to 250 MHz. The CPU of the first and second generation Raspberry Pi board did not require cooling with a heatsink or fan when overclocked, but the Raspberry Pi 3 may generate more heat when overclocked. RAM. The early designs of the Raspberry Pi Model A and B boards included 256 megabytes of random access memory. Of this, the early beta Model B boards allocated 128 megabytes to the GPU by default, leaving only 128 megabytes for the CPU. On the early 256 megabyte releases of Models A and B, 3 different splits were possible. The default split was 192 megabytes for the CPU, which should be sufficient for standalone 1080p video decoding or for simple 3D processing. 224 megabytes was for Linux processing only, with only a 1080p frame buffer, and was likely to fail for any video or 3D. 128 megabytes was for heavy 3D processing, possibly also with video decoding. In comparison, the Nokia 701 uses 128 megabytes for the Broadcom Video Core 4. The later Model B, with 512 megabytes of RAM, was released on the 15th of October 2012 and was initially released with new standard memory, split files, ARM 256, Start ELF, ARM 384, Start ELF, ARM 496, thus with 256 megabytes, 384, 496, 256, 16 video RAM, respectively. But about 1 week later, the Foundation released a new version of start.elf that could read a new entry in config.txt GPU mem equals XX and could dynamically assign an amount of RAM from 16 to 256 megabytes in 8 megabyte steps to the GPU, obsoleting the older method of splitting memory, and a single start.elf worked the same for 256 megabytes and 512 megabytes Raspberry Pis. The Raspberry Pi 2 has 1 gigabyte of RAM. The Raspberry Pi 3 has 1 gigabyte of RAM in the B and B Plus models and 512 megabytes of RAM in the A Plus model. The Raspberry Pi 0 and 0W have 512 megabytes of RAM. The Raspberry Pi 4 is available with 1, 2, 4, or 8 gigabytes of RAM. A 1 gigabyte model was originally available at launch in June 2019, but was discontinued in March 2020, and the 8 gigabyte model was introduced in May 2020. The 1 gigabyte model returned in October 2021. The Raspberry Pi 5 is available with 2, 4, or 8 gigabytes of RAM. Networking. The Model A, A+, and Pi 0 have no Ethernet circuitry and are commonly connected to a network using an external user-supplied USB Ethernet or Wi-Fi adapter. On the Model B and B+, the Ethernet port is provided by a built-in USB Ethernet adapter using the SMSC LAN 9154 chip. The Raspberry Pi 3 and Pi 0W wireless are equipped with 2.4 GHz Wi-Fi 802.11n, 150 megabits per second, and Bluetooth 4.1, 24 megabits per second, based on the Broadcom BCM 43438 full MAC chip, with no official support for monitor mode, though it was implemented through unofficial firmware patching. And the Pi 3 also has 10 100 megabits per second Ethernet port. The Raspberry Pi 3B Plus features dual band IEEE 802.11 BGNAC, Wi-Fi, Bluetooth 4.2, and Gigabit Ethernet, limited to approximately 300 megabits per second by the USB 2.0 bus between it at the SoC. The Raspberry Pi 4 has full Gigabit Ethernet. Throughput is not limited as it is not funneled via the USB chip. Special purpose features. The RPI 0, RPI 1A, RPI 3A+, and RPI 4 can be used as a USB device or USB gadget plugged into another computer via a USB port on another machine. It can be configured in multiple ways, such as functioning as a serial or Ethernet device. Although originally requiring software patches, this was added into the mainline Raspbian distribution in May 2016. Raspberry Pi models with a newer chipset can boot from USB mass storage, such as from a flash drive. Booting from USB mass storage is not available in the original Raspberry Pi models. The Raspberry Pi 0, the Raspberry Pi Pico, and the Raspberry Pi 2A models, and the Raspberry Pi 2B models with versions lower than 1.2. Peripherals. Although often pre-configured to operate as a headless computer, the Raspberry Pi may also optionally be operated with any generic USB computer keyboard and mouse. It may also be used with USB storage, USB to MIDI converters, and virtually any other device component with USB capabilities, depending on the installed device drivers in the underlying operating system, many of which are included by default. Other peripherals can be attached through the various pins and connectors on the surface of the Raspberry Pi. The Model 2B boards incorporate 4 USB Type A ports for connecting peripherals. Video. The video controller can generate standard modern TV resolutions such as HD and Full HD and higher or lower monitor resolutions, as well as older NTSC or PAL standard cathode ray tube TV resolutions. As shipped, i.e. without custom overclocking, it can support the following resolutions: 640 x 350 EGA, 640 x 480 VGA, 800, all this stuff. An early Raspberry Pi Model A with an HDMI port and a standard RCA composite video port for older displays. High resolutions up to 200 or 2048. Higher resolutions up to 2048 by 1152 may work, or even 3840 times 2160 at 15 Hz, too low a frame rate for convincing video. Allowing the highest resolutions does not imply that the GPU can decode video formats at these resolutions. In fact, the Raspberry Pis are known to not work reliably for H.265 at those high resolutions. Commonly used for very high resolutions, however, most common formats up to full HD do work. Did I read this? An early Raspberry Pi model with an early Raspberry Pi 1 Model A with an HDMI port and a standard RCA composite video port for older displays. Although the Raspberry Pi 3 does not have H.265 decoding hardware, the CPU is more powerful than its predecessors, potentially fast enough to allow the decoding of H.265 encoded videos in software. The GPU in the Raspberry Pi 3 runs at higher clock frequencies of 300 MHz or 400 MHz compared to previous versions which ran at 250 MHz. The Raspberry Pi can also generate 576i and 480i composite video signals as used on old-style CRT TV screens and less expensive monitors through standard connectors, either RCA or 3.5mm phono connector depending on model. The television signal standards supported are PAL BGHID, PAL M, PAL N, NTSC, and NTSC-J. Real-time clock. When booting, the time defaults to begin. When booting, the time defaults to being set over the network using Network Time Protocol (NTP). The source of time information can be another computer on the local network that does not have a real-time clock, or to a NTP server on the internet. If no network connection is available, the time may be set manually or configured to assume that no time passed during the shutdown. In the latter case, the time is monotonic. Files saved later in time always have later timestamps, but may be considerably earlier than the actual time. For systems that require a built-in real-time clock, a number of small low-cost add-on boards with real-time clocks are available. The Raspberry Pi 5 is the first to include a real-time clock. If an external battery is not plugged in, the Pi 5 will use the Network Time Protocol or will need to be set manually, as was the case in previous models. The RP2040 microcontroller has a built-in real-time clock, but it cannot be set without some form of user entry or network facility being added. Connectors. Pi Pico. Oh, and it's got a scroll. Okay, hold on. Alright, this will take a little while to use the scroll over. Okay, connectors. Location of connectors and main ICs on Raspberry Pico. It's kind of small. Okay. Still cut it off. 40 pins, GPIO, I2C, SPI, UART. Oh, what a shame, because I like pictures. And it's hard to see all this stuff. Shows all the different connectors. Do I really need to look at all the different connector types of the different boards? Let's look at the connector types of the Pi 4 and the Pi 5. That makes sense to me. Alright, that'll do. This is the Raspberry Pi Model 4B, and it has status LEDs. Micro SD slot on bottom side, 40 pins, 28X, GPIO, I2C, SPI, UART, Wi-Fi BT dual band, Raspberry Pi 4 Model B, Raspberry Pi 2018, CPU/GPU, Broadcom, BCM 2711, ARM Cortex-A72, DRAM 1 GB, 2, 4, or 8. Can't even read this stuff. 1 GB Ethernet RJ45, 2 times USB 3, 2 times USB 2, 3.5mm out composite video to audio something, HDMI out, USB-C, power in. Maybe I can get some of the zoomed in stuff I couldn't get before. So this is 2 times USB 3 plus 2 times USB 2 controller and Gigabyte Ethernet controller. USB decoupling cap. Okay, here's the Pi 5. I don't know what's different. Looks a lot the same. Oh, this is still the Model 4. Okay, this is the 5. So what's different? HAT and GPIO interface, memory, MIDI, cam video, analog, voice out, 2 times USB 3.0, Giga Ethernet. Well, pause and look, I guess. Yeah. Okay, this would have been a nicer thing to look at, but it's okay. J8 header and general purpose input-output GPIO. Raspberry Pi 1 models A+, B+, Pi 2 model B, 3 models A+, B, and B+, Pi 4, and all this stuff have the same 40-pin output designated J8 across all models. Raspberry Pi 1 models and A and B only have the first 26 pins. The J8 header is commonly referred to as the GPIO connector as a whole, even though only a subset of the pins are GPIO pins. In the Pi 0 and 0W, the 40 GPIO pins are unpopulated, having the through holes exposed for soldering instead. The 0WH wireless and header has the header pins pre-installed. Okay, unfortunately I'm not getting it all on the screen. Do I need to read all this out? Well, I guess I'm covering it. Okay, I'll just go down the and then the numbers aren't even in order. Well, I'll just read the functions out. 3.3 volts, SDA, I2C, SCL, I2C. GC clock, ground, Gen 0, Gen 2, Gen 3, 3.3 volts. MOSI, SPI, MISO, SPI, SC clock, SPI, ground. ID, SD, I2C, not applicable, ground. 5 volts, ground. Transmit, D0, UART. RDX or RxD0, UART. Gen 1, ground, Gen 4, Gen 5, ground, Gen 6, CEON, which is chip select CS or slave select, CE1, SPI, IDSC, I2C, ground, NA, digital in, digital out. Model B revision 2 also has a pad called P5 on the board and P6 on the schematics of 8 pins, offering access to an additional 4 GPIO connections. These GPIO pins were freed when the 4-board version identification links present in revision 1.0 were removed. GPIO function, GPIO Gen 7, GPIO Gen 9, ground, 3.3 volts, Gen 8, Gen 10. Models A and B provide GPIO access to the ACT status LED using GPIO 16. Models A Plus and B Plus provide GPIO access to the ACT status LED using GPIO 47 and the power status LED using GPIO 35. Specifications, and it's going to be one of these scroll over type of things. And it relates to all the different models, which at this point is becoming not that interesting to me. But I guess this is helpful if you've got a Pi and you're looking up stuff. Yeah, I simply can't cover that on the camera very well. Simplified B model change log. Stuff's not that interesting to me at this point. Software. Operating systems. Raspberry Pi provides Raspberry Pi OS, formerly called Raspbian, a Debian-based Linux distribution for download, as well as third-party Ubuntu, Windows 10 IoT Core, RISC OS, Libre Elec, specialized media center distribution, and specialized distributions for Kodi Media Center and classroom management. It promotes Python and Scratch as the main programming languages, with support for many other languages. The default firmware is closed source, while unofficial open source firmware is available. Many other operating systems can also run on the Raspberry Pi. The formally verified microkernel Cell 4 is also supported. There are several ways of installing multiple operating systems on one MSD card. Various operating systems for the Raspberry Pi can be installed on a micro SD or SD card, depending on the board and available adapters. Seen here is the micro SD slot located on the bottom of a Raspberry Pi 2 board. That may be. Other operating systems not Linux nor BSD based. Alright, so maybe in my next video I can pick up at the other operating systems not Linux nor BSD based. I don't know if I want to read all this stuff out. Do I want to know all the different operating systems? Doesn't sound like something I want to read. So maybe I could skip it. It starts to talk about some more interesting things. I'm not saying that's what this is interesting. Firmware, third-party software, software development tools, accessories. Well, that might be interesting. I might want to learn more about the accessories. Vulnerability to flashes of light, reception and use, community, education, home automation, industrial automation, commercial products, COVID-19 pandemic, AstroPi, and Proxima. The history might be interesting. pre-launch, launch, and then it's got post-launch. This is the history, I guess, all the developments of it. Sales, supply and demand difficulties. And then it has references. Well, I'll have to choose if I want to cover more of that in my next video, when I get to covering that.